Okay, welcome once again. Today we're going to look at using absolute value in real-world applications. So we're going to look at some various examples that'll show you how you can use absolute value, come up with equations, and find the answers to absolute value word problems. So Sydney Harbour Bridge in Australia is 1,149 meters long. Because of changes in temperature, the bridge can expand or contract by as much as 420 millimeters. Write and solve an absolute value equation to find the minimum and maximum lengths of the bridge. Now, before we start, remember, guys, that the 420 is in millimeters, and the length of the bridge is in meters. We want those to be the same. So millimeters, we can write as meters by making this into 0.42. So with that in mind, our optimum value, what we want the bridge length to be, is 1,149 meters. That's what we want the bridge to be. And that's really, when we're talking about an absolute value equation, that's our midpoint value. That's what we want it to be. But we're allowing the bridge to vary by as much or as little as 0.42 meters, which is 420 millimeters. Because remember, there's 1,000 millimeters to 1 meter. So it's a little less than half a meter. Okay, and that's the distance from that midpoint value. So that's how much we're allowing it to be, bigger or smaller. So if you think in terms of a segment, or what we've been doing in the past, we can go plus 0.42 or minus 0.42, if you think about it in terms of a segment. So our absolute value equation would be our x minus 1149 equals 0.42. Once again, this is what we want it to be, and this is how much we're allowing it to vary by. Okay, so it can go up or down by 0.42. Same thing we've been doing, but now we're doing it with real life problems. So obviously there's going to be two answers, guys, the minimum and the maximum. The minimum is going to be when we take away 0.42, or if you think about it in terms of the segment drawing that we've been using, when you're going to the left, right? And that would give you a total value of 1,148.58 meters. If we're going the opposite direction to the right, in other words, we're making it bigger, we're allowing it to expand a little bit, then we're going to add that 0.42. So it's going to give us 1,149.42 meters. Not a lot of space, but we have to let the bridge allow to, quote unquote, breathe. Okay, temperature changes make things expand or contract. And that's what's happening here. So let's look at another example. We're still looking at this bridge, but now we're looking at it expanding and contracting in a different way. It says the Sydney Harbour Bridge is 134 meters tall. So we're talking about a difference in height. The height of the bridge can rise or fall by 180 millimeters because of changes in temperature. Write and solve an absolute value equation to find the minimum and the maximum heights. So once again, you can see that we have meters and millimeters, so we want to change this to meters, which would be 0.18. So we want the bridge to be 134. That's the optimum value. And another way of thinking about that, once again, if we're thinking about our segment, is that that's the midpoint. But we're allowing it to vary by 0.18 meters, which is the same as 180 millimeters. That's the distance from the midpoint. So we can either make it 0.18 more or 0.18 less. So there's our absolute value equation. The 134 is the optimum value. That's what we want it to be. But we allow it to vary by 0.18. So it could be less 0.18 or more 0.18. If it's less, it's 134 minus 18, which gives us 133.82 meters. And if we add that 0.18, it's 134.18. So there's our minimum value and our maximum value. Let's do a couple more. In different applications. Okay, so here we're talking about Barry's walkie-talkie has a range of 2 miles. Barry is traveling on a straight highway and is at mile marker 207. Write and solve an absolute value equation to find the minimum and maximum mile markers from 207 that Barry's walkie-talkie will reach. All right, so our midpoint value is 207. That's where Barry is. He's at marker 207. And we're allowing the range of the walkie-talkie to be 2 miles more or less. So we're allowing it to vary by a distance of 2 miles from that midpoint value. So our absolute value, once again, 207 is what we want, but we're allowing it to vary by 2. 2 more or 2 less. So 2 less would be 205. 2 more would be 209. Let's look at one more. A little bit of problem with manufacturing. A quality control inspector at a bolt factory examines random bolts that come off the assembly line. Okay, so his job is to check to make sure that the bolts are within a certain size. If they're too big or too small, they have to be thrown out. So any bolt whose diameter differs by more than 0.04 millimeters from 6.5 millimeters is sent back. They have to remake them. Okay, write and solve an absolute value equation to find the maximum and minimum diameters of an acceptable bolt. Okay, so once again, we want 6.5 millimeters. That's how much we want the diameter to be. But we're allowing it to vary by as little as 0.04 millimeters. It's not a lot, but that's you have to be pretty exact when you're talking about creating a bolt or something that small. So we're allowing it to be 0.04 millimeters bigger or smaller. So once again, we want it to be 6.5, but we're allowing it to vary by 0.04. So we can either take away that 0.04, or we can add the 0.04. There's our minimum value, 6.46 millimeters, and our maximum value would be 6.54 millimeters. That's it. Gives you some idea of how we can solve these problems. If you have any questions, feel free to email me or bring up your questions in class. See you soon.